Good morning, students. So today we can learn about chapter 5, magnetism and electromagnetism. Already we learned first 4 chapters. Today 5th chapter we can learn about magnet. Already you have learned about magnet. Okay. So magnet, lower classes you have learned about magnet. Then olden days they used magnet. No, what purpose they used to do? No, they used magnet for ship. For what purpose means to identify the direction. In the ship, to identify direction, magnets are used. There are two types of magnets. One is the natural magnet. Natural magnet. Another one, artificial magnet. There are two types of magnet, natural magnet and artificial magnet. What's the difference? Natural magnet means it came as nature. From the rock they will take natural magnet. So always it is permanent. The magnetic power is permanent. But artificial not like that. When we heat the magnetic power will lose the magnetic power in artificial magnet. But the permanent magnet, it does not lose the magnetic power. Always permanent. So a strong natural magnet is magnetite. Magnetite, a lodestone magnetite. A strong natural magnet is, what is that? Lodestone magnetite. A strong natural magnet is lodestone magnetite. Then we can see the artificial magnet. This artificial magnet nowadays also from the shop it is available. This is one of the artificial magnet. So we will say this as a Bohr magnet. What is this? Bohr magnet. This Bohr magnet has two poles. One side north pole, another side south pole. In the pole only magnetic power is there. Okay. So here like poles attracted, unlike poles attracted. See this unlike means south, north, attracted. The like poles, what happens? Repel. So unlike poles attracted. Now I am drawing the Bohr magnet. Suppose this is the Bohr magnet. Yes, suppose north pole and south pole. Two poles are there, north pole and south pole. The magnet is there, we can say two poles are there, north pole and south pole. But how will we identify whether it is north pole or south pole? How we can identify is by using magnetic needle. What is that? Magnetic needle. By using the magnetic needle, we can identify the poles. Now listen here, the magnetic needle. The magnetic needle has a needle. See, this is the magnetic needle. It has a pointer is there. Arrow mark is there. No, that area only north pole. Arrow mark there. No, the pointer has an arrow mark. That is which pole? North. Now listen the pointer, arrow mark there, no, this is the north pole. I am bringing this magnet, suppose this north pole. So this south pole, this one north pole. So towards attracted. North pole and south pole are attracted. So we can write this as south pole. Okay, this magnet is south pole. Then I am turning this magnet. Just to listen the pointer. It move away from the magnet. So this is the north pole, this north pole. Okay, away from the magnet means this pointer is away from the magnet, north pole. Pointer is towards the magnet is called south pole. So like that we can identify the north pole and south pole. See, this is the magnetic needle. Magnetic needle has a pointer, arrow mark there, no, that is north pole. How we can identify? This arrow mark is towards means south pole, away from the magnet means north pole. So here away from the magnet, the pointer is here, arrow mark is here, away from the magnet. So we can say this is north pole and this towards the Arrow mark is towards the magnet, so we can say this as the south pole. Next one is magnetic field. So suppose this is the magnet and two poles are there. Two poles are there, north pole and south pole. So the space, the region around the magnet, this region around the magnet where the force of influence is called magnetic field. So the region around the magnet which is a magnetic field. The region around the magnet through which the force of influence are called magnetic field. Now we can draw the magnetic lines of force by using the magnetic needle. We can draw. Suppose here this north pole. When we are keeping here magnetic compass, then put a dot. Suppose here north pole we are keeping, put a dot. The arrow pointer will show north. So like that you can keep this north pole and thus keep the magnetic needle. Pointer will show where it will show the arrow mark. There you can put the point. So like that here also, here, like that. Then from the always the magnetic lines of force start from the north pole and ends at the south pole. And here also start at the north pole and ends at the south pole. The next line also start with the north pole and ends at the south pole. Here also. So now see, this line does not intersect each other. Here the lines, magnetic lines of force is there, no, does not intersect each other. But here the Bohr magnet, near the poles only magnetic power is there, no. So here crowded areas are there. So near the poles, crowded area, but here they should not intersect each other. Both lines should not intersect each other. Now the arrow mark you can draw like this. It's always closed curve. So why arrow mark means from the north pole it started, the magnetic lines of force start from the north pole and ends at the south pole. So two lines if you draw means should not intersect each other. These are the properties of magnetic lines of force. Okay, it starts from north pole to south pole and it is a closed curve. The magnetic lines of force are the closed curve and it has the magnitude and direction. So this is the magnitude and it has certain directions. So this is the magnetic lines. How to draw the magnetic lines of force. First we have learned about magnetic field and how we can draw the magnetic lines of force. Now see, suppose this is the magnetic lines of force. Magnetic lines of force crossing through a certain area. Suppose this is the certain area. The magnetic lines of force crossing through a certain area is the normal to the lines of force. Okay, the crossing through the certain area and normal to the lines of force. So that is the magnetic flux density. So the magnetic lines of force crossing through a unit area, some area, and normal, always perpendicular to this line. This area is perpendicular to this line. So that is called magnetic flux density. Magnetic flux denote the letter phi. What is that? Magnetic flux denote the letter phi. Magnetic flux denote the letter phi. The unit of magnetic flux is Weber. W-E-B-R. Weber. We can write like this. W-B also we can write. Okay. So the magnetic flux, the magnetic lines of force crossing through a unit area normal to the field lines. So that is magnetic flux density. Magnetic flux denote the letter phi. The unit of magnetic flux is Weber. So we can write W-B also. We can Weber or we can write W. Okay. So far we have learned about magnet. What are the two types of magnet? Natural magnet and artificial magnet. The strongest natural magnet, lodestone and magnetite. The strongest natural magnet. So artificial magnet, we saw that Bohr magnet is the artificial magnet. From the shop also we can get this Bohr magnet. This is artificial magnet. When we heat this magnet, you lose the magnetic power. And the magnetic field means the region around the magnet through which the force is influence is called magnetic field. How we can draw the magnetic lines of force? By using this magnetic compass, we can draw the magnetic lines of force. Always the magnetic lines of force start from the North Pole and ends at the South Pole. And here also start from the North Pole and ends at the South Pole. And the lines should not intersect each other. See, should not intersect each other. So field lines, magnetic field lines should not intersect each other. It starts from North Pole to South Pole and it has the magnitude and direction. The magnetic field lines has magnitude and direction. So these are the properties of magnetic field. And the next one is the flux. Magnetic flux denote the letter phi. The unit of magnetic flux is Weber, that we can say WB. And what is magnetic flux density? So the magnetic lines of force crossing through a unit area is normal to the field force. So that is the magnetic flux density. So this is a book by question, magnetic flux density. So this much can you understand, students? Next one is magnetic effect of current. Magnetic effect of current. See, already last lesson we have learned about magnetic effect of current. That is always perpendicular to the magnetic field. A current carrying conductor, the direction of current is always perpendicular to the magnetic field. That is magnetic effect of current. Now see the scientist Hans Oersted, he demonstrated about the experiment about the magnetic effect of current in a class. Okay. So that on the table he kept that magnetic compass. You know that magnetic compass. He kept the magnetic compass and the current he had a circuit now. So in the current passes through the circuit. When he switch on the circuit, the magnetic needle will show deflection. That means what? The needle will move here and there. That's a deflection. It shows deflection. When we switch off the current, what happens? That it does not show the deflection. So from there we can find out when the current passes through the conductor, what happens? The magnetic compass shows deflection. From there, this experiment, I am drawing the diagram. Just listen. This magnetic needle. Fix two magnetic needle. Is the resistor, battery, now suppose this circuit is open. Suppose here circuit open, no, here not closed, open. Open means the current does not flow through the conductor. So the current flows this direction. So the circuit open means current does not flow the conductor and the magnetic needle does not show the deflection. Suppose the circuit is closed. Now the circuit is closed. Now what happened? The current from the battery, the current passes through the battery and it falls on the magnetic compass is there. No, this A and B. Two magnetic compass are attached, A and B. The current passes through this conductor. What happens means the magnetic compass shows the deflection. So how it shows the difference? When the current flows through the conductor, the magnet is always perpendicular to the magnetic field. Like that only magnetic effect of current will have there. No. So always the current flows this direction is always in perpendicular direction. So it shows the first compass is there. No, it shows east direction is east direction and the second magnetic compass shows the west direction. Okay, when the current passes through the conductor, what happens? The first magnetic compass shows which direction? East direction and the second one the west direction. So from this we can find out that the current carrying conductor the magnetic compass also shows the difference. So this is the magnetic effect of current. Okay. Now next the force carrying a conductor. Suppose here when the current passes, some force is there. No, the force carrying a conductor F equal to I means what? The current flows through the conductor. Then B, L. L means what? Length of the conductor. So length of the conductor. I means the current carrying conductor. L, length of the conductor. Then B. B means what? Magnetic. Okay. This three. When the force carrying conductor, what and all there? The current carrying conductor is the length of the conductor and the magnetic field. So the force carrying a conductor equal to I into L into B. This is the formula for force. Okay. By using this formula, we can find out the force. The problem is there. The current they will give and the length given and the magnetic field also given. Just you can multiply and find out the value of force. Okay, how much force carrying in a conductor we can find out by using the formula. So your solved problem is there. After that we can do. Before that we can learn the Fleming's left hand rule. Fleming's left hand rule. Fleming's left hand rule. First, stretch three fingers. See, stretch three fingers. What are the finger? Middle finger, second finger, and thumb. Okay, what are the fingers? Stretch three fingers. What and all? Middle finger, second finger, and thumb. Three also mutually perpendicular to each other. See, stretch three finger, middle finger, second finger, and thumb. Three also mutually perpendicular to each other. So all of you know, first stretch three finger, middle finger, second finger, and thumb. Okay, so three also mutually perpendicular to each other. The middle finger shows the direction of current. What is that? The middle finger shows the direction of current. Then the second finger shows the direction of magnetic field, and the thumb shows the direction of force of a conductor. Okay. Then see the three finger. What are the three finger? Middle finger, second finger, and thumb. Three also mutually perpendicular to each other. The middle finger shows the direction of current. The middle finger shows the direction of current. Second finger shows the direction of magnetic field. Thumb shows the direction of motion of a conductor. Okay, so this is the Fleming's left hand rule. This is very important question. You have to learn Fleming's left hand rule. Like the right hand rule also there. Next class we can see the right hand rule. First Fleming's left hand rule. Once again, stretch three finger. What are the finger? Middle finger, second finger, thumb. So three also mutually perpendicular to each other. The middle finger shows the direction of current, and the second finger shows the direction of magnetic field. Thumb shows the direction of motion of a conductor. So these are the Fleming's left hand rule. Then we can do the problem. Problem number 1, F equal by using this which formula? F equal to IL. Now take your book, students. Page number 56, problem number 1. I am reading a conductor of length 50 centimeter carrying a current 5 ampere placed perpendicular to the magnetic field of induction 2 into 10 power minus 3. Find the force of a conductor. What and all given? First you have to write length. How much given? 50 centimeter. And current 5 ampere. And then magnetic field is given 2 into 10 power minus 3. Now listen, students. First given, you have to write given. Current I, how much given? 5 ampere. Then length it is given. How much given length? 50 centimeter. 50 centimeter. The centimeter you have to change into meter. So what I have to do? 50 into 10 power minus 2 meter. So just change centimeter to meter. That's a 10 power minus 2. Then magnetic field it is given that 2 into 10 power minus 3. So this much given in the question. So you know the formula. What's the formula? Force F equal to I L B. So just multiply 5 into L value 50 into 10 power minus 2 into B value 2 into 10 power minus 3. So 5 into this 10 power minus 2 we can take 50 divided by 100. 10 power 2 means 100 minus 2 numerator minus 2 denominator means 10 power 2. So 50 divided by 100 into 2 into 10 power minus 3. Just cancel 0 and 0. Then 1 5 is 5, 2 5 are 10. Then 2 and 2 cancel. So you get the answer 5 into 10 power minus 3. What is the unit of force? Newton is the unit of force. So like that you have to do. First what is given you have to write that formula, then substitution, answer and what you have to find, force you have to find. The unit of force is Newton. So answer you have to write 5 into 10 power minus 3 Newton. Next one, problem number 2. A current carrying conductor of certain length kept perpendicular to the magnetic field experiences a force F. What will be the force of the current is increased 4 times, length is halved and magnetic field is doubled. So here what is given you have to write. First current given. No, current given and length given. Length half it is given, so 1 by 2. Then the tripled given a magnetic field, so here 3p you have to write length 4 here. So just you have to multiply means you will get 6 value you will get, and the unit of force is 6. Then therefore the force increases 6 times. 6 times of force is given. So like that you have to do and see. If you have any doubt you can ask. Okay, then Rome letter 5, answer in brief. The first question, state Fleming's left hand rule. That page number 56. The law states that while stretching the 3 fingers of left hand is perpendicular, if the direction of the current is denoted by the middle finger of the left hand and the second finger is for the direction of the magnetic field, then the thumb of the left hand denotes the direction of force of the movement of the conductor. Second question, define magnetic flux density. Page number 53. The number of magnetic field lines crossing unit area kept normal to the direction of the field lines is called magnetic flux density. The unit of magnetic flux density Weber per meter square. Next one, chapter 4, Rome letter 7, problem number 1. Rubbing a comb on hair makes the comb gets minus 0.4. A. Find which material has lost electron and which one gained in it. Find how many electrons are transferred in this process. The first answer, hair has lost electrons and become positively charged. Comb has gained electrons and become negatively charged. B part, charge of 1 electron, already have learned this value, 1.6 into 10 power minus 19 coulomb. You know the formula for charge, Q equal to Ne. From here, number of electrons only you have to find out, so N equal to Q divided by E. The number of electrons in 1 coulomb equal to 1 divided by 1.6 into 10 power minus 19. So divide means you will get 6.25 into 10 power minus 10 power 19 electron. This numerator it will go now, so it will become plus. The number of electrons equal to 0.4 Celsius it given. Then coulomb is given. Then just you have to divide and you will get the answer minus 2.5 into 10 power 9 electrons. The second question, calculate the amount of charge that would flow in 2 hours through an element of an electric bulb drawing a current of 2.5 ampere. First you have to write given I equal to current I equal to 2.5 ampere, time equal to 2 hours is given. Then the current I equal to Q by T, charge by time. So from here charge you have to find Q equal to I into T. Just you have to divide, multiply, you will get the answer. Hour change into second, that's 60 into 60. Multiply means you will get this answer. So Yes, today's assignment, 2 questions. State Fleming's left hand rule and magnetic flux density. 2 questions, study and write in that note. Already 4 lessons over, 5th lesson assignment, only 2 questions. Thank you.